Am I audible to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, today we are going to see the first unit. What is elasticity? Yeah, many times on the last 2 days, I repeated the elasticity is only the one property of the matter, solid matter. We are going to study on this unit. So, the topics covered in this unit are elasticity, stress strain diagram and its uses, and what are the factors affects the elasticity, its tensile strength, torsional stress and deformations, twisting couple, torsion pendulum, its theory and experiment, bending of means, bending moment, cantilever, its theory, cantilever theory and experiment, uniform and non-uniform bending, its theory and experiment, high-shaped girders, stress due to bending in beams. Actually, we don't know what type of the question pattern you will be getting, whether it is a objective type, that is a multiple choice questions or fill up, or as usual detailed parts, part A, part B. Part A contains 10 2 marks and part B contains 5 16 marks. Actually this is the pattern, but due to this pandemic you have to ready to face any type of question paper. If it is an online exam means it may be the multiple choice question. If it is a direct written exam means part A and part B 2 marks and detailed questions. Detailed question na idhula actually you have that twisting couple torsion pendulum is one detail. Twisting couple is one 8 marks. Torsion pendulum on this topic. Torsion pendulum is a 16 mark question. Bending moment, next one, bending moment is a 16 mark question. Cantilever is a 16 mark question. Uniform and non-uniform bending is a 16 mark question. I-shaped griddle is a 4 marks like that. 4 marks, 2 marks, the topics. So totally you have details, other things, the stress strain and all subdivisions. If they ask twisting couple for a 10 or 12 marks means the remaining 4 or 6 marks are given to stress strain diagram or its factors affecting elasticity or I-shaped gridders. Like that you may face some subdivisions in the question paper. So main detail nu pathina twisting couple, torsion pendulum, cantilever, uniform and non-uniform bending. 4 questions are there. Okay. Now we will go to the topic. So if you want to study the elasticity, you should have the knowledge about the what is meant by stress, what is meant by strain, what is the elastic limit, like that you should have some knowledge about that. Types of moduluses, what is meant by stress. Usually என்ன சொல்லுவோம் stressனா it becomes more stressன்றது some type of pressure. It's a it you are giving force to one particular object. அந்த ஒரு particular ஏரியாக்கு நீ எவ்வளவு force கொடுக்கற அதுதான் stress. Here it is called as the restoring force per unit. So the stress is calculated. How the stress to be measured? Generally சொல்லணும்னா stressன்றது it is one type of depression, one type of pressure you are giving. How it is measured? So in definition it can be written as restoring force per unit area. Mathematically we can write it as F divided by A. What is the unit of stress? Then what is the unit of stress? Force per unit area is the mathematical definition of stress. Na? What is the unit of stress? Force is a unit. Anyone unmute and say the answer, or otherwise I will call the name.
Newton.
Force is Newton. Divide denominator area. What is the unit of area?
Meter.
Meter?
Meter per second.
Square. Meter
No.
square.
Meter square. Usually length or breadth அப்படின்னும் போது dimension measure பண்ணும்போது its unit is meter. Area means length into breadth. So meter into meter, meter square. Volume means area into length again. So meter cube. சரியா? So area என்னும்போது meter square. So denominator force na Newton. In the numerator Newton divided by meter square. The unit of stress is Newton per meter square. So stress is just how much force you are applying, or how much load எவ்வளவு கொடுக்கிற, overloadன்னு சொல்லுவோம். That is the load, the stress, how much load you are giving to any particular object. அந்த load பொறுத்து தான் அந்த அதனுடைய strain இருக்கும். So the strain, how do you measure the strain? நீ கொடுக்கிற stress பொறுத்து the body will strain. How do you measure the strain? The strain is the any work has to be done. அந்த ஒரு work நடக்கணும்னா நீ அதுக்கு force apply பண்ணணும். When you apply the force to the body causes changes. Some change will be happen. And the change நடக்குது பத்தியா, that is called as strain. You are strained. If actually what is the stress I am giving to you? You have to attend the class by 2:10. That is a stress. Nee strain panni you are logging. That is strain. If I am giving stress, if you are not taking any effort, means that is strain is 0. Na stress kudukren இந்த டைமுக்கு இதுதான் schedule. Generally பேசணும். When you talk physically, what the stress we are giving, that is the workload we are offering for you, and simultaneously you are working for that. That is the strain you are produced. ரெண்டுமே ஈக்குவலா இருக்கணும், எதுவுமே எதையும் தாண்டி போயிடக்கூடாது. That is the limit, the stress and strain. How do you measure the strain? Strain எப்படி measure பண்ணலாம்? Now the ratio of change in dimension to the original dimension. How do you write it mathematically? Strain mathematically எப்படி எழுதுவ?
L dash by L.
L by L. Okay, L dash by L ன்னு எழுதலாம். That is ratio. ரேஷியோனாலுமே அங்க ஒரு denomination வந்துரும். Ratio of change in dimension to the original dimension. So what is the unit of strain?
No unit.
No unit, because it is both the same dimension. If the area changes, how the area will be changes from the original area only. Area to area only. Volume change ஆகுதுன்னா அதோட original volumeல இருந்து தான் அதோட new volume create ஆக போகுது. If the length changes, now how the new length will arrive? From the original length. So that is called as the strain. No unit. ஏன்னா அந்த length na meter divided by meter. Volume divided by volume na meter cube divided by meter cube. So both will getting cancelled. Finally, strain, no unit. You have no unit for strain. Stress is Newton per meter square. And a linear strain, lateral strain, alpha and beta, we can measure it by the two different strains. Linear na, if you applied any force, if the body moves linearly and along the length only, okay. And if it moves along the length na, that is linear strain. We can use the term alpha to measure linear strain. If the force I applied, na apply பண்ற force நால, if it is the length changes perpendicular, if the length will be changes due to the perpendicular force I applied, the shearings படிச்சிருப்ப அந்த மாதிரி ஒரு change நடந்துச்சுன்னா, that is called as the lateral strain, beta. And what is the limit? I already told you, ரெண்டுமே ஒரு லிமிட்டா இருக்கணும். Stress should not go beyond strain. It should be dimensionally equal. That is the limit. The maximum stress that can be applied to the substance becomes, before it becomes permanently deformed and it does not return to its initial length. That is the elastic limit. Now suppose if you are going to buy vegetables in the vegetable market, you will buy one carry bag. Usually the nature of the plastic carry bag is it's a more elasticity it has with it. Basically it can carry up to 15 kg. ஒரு elastic bag cover தான், just it is an elastic cover, plastic cover னு கேட்டு வாங்குவோம். Now it is banned and that plastic cover has an ability to carry 15 kg. அதோட ability 15 kg அப்படின்னும் போது நீ மேல அதோட weight add பண்ணினா, you are buying the onion, you are buying some vegetables, fruits, everything to be filled in same carry bag. na at one stage what happens, அதுக்கு லிமிட்டே இவ்வளவு ஒரு 5 kg தான் fill பண்ண முடியும். But because of its elasticity you are loading more stress to that body. அதான் the stressன்றது தான் loading. stressன்றது load. நீ மேல load போட்ட அப்படின்னும் போது finally it crosses the elastic limits, that the bag will turn out. That is the elastic limit. If you maximum stress, that is called as the maximum stress that can be applied to the substance before it becomes permanently deformed and does not return to its initial length. And the மேல போச்சுனா that body does not return to the initial length. That is called as the elasticity. இது the elastic carry bag மட்டும் கிடையாது. It will be happens in all solid materials. எல்லா ஒரு மெட்டீரியலுமே இந்த நேச்சரை தெரிஞ்சாதான் அதோடைய பர்டிகுலர் யூசேஜை ஐடென்டிஃபை பண்ண முடியும். Okay, so what is the elasticity means? It is the property of your body by the virtue of which deforms the application of deforming force. ஒரு பாடி எலாஸ்டிக் பாடின்றதை எதை சொல்லுவோம்னா, the deforming force அப்ளை பண்ணும்போது the body should extend. It should extend, elongated. We can call it as elongated. The body shape will be deformed, not it takes the new shape or new length due to the elongation. Due to the load you applied, the body deforms. When you remove the load, the body should return back to its original state. Okay, that is called as that type of property is called as the elasticity. The plasticity is totally opposite to this. That is, the body does not return back to its original state. It will also deform. If you apply the force to the body takes deformation but never regain its original position. That is அதோட ஏன்னா அதோட restoring force அங்க 0. அந்த பேர் தான் plasticity. The elasticity means those bodies have the restoring force. That is restoring, that it has an ability to regain its original shape or dimension. The body, very simply you can write, உள்ள பெரிய 3 லைன்ல எழுதணும் கூட அவசியம் கிடையாது. The ability of your body to regain its original shape. And the regain its original shape தான் restoring force வச்சு calculate பண்றோம். And that is regain its original shape is called as the elasticity. Examples are given. Shock absorbers of vehicles. நம்ம the bike, car எல்லாத்தையும் யூஸ் பண்ற அந்த alloys, அது வந்து அந்த shock absorber ஃபுல்லாவே elastic. When you ride on the bumpers, when it moves ups and downs, when you face the ups and downs on the roads, this elastic shock absorbers, it has an elastic compressed. When you ride on that bumps, when you move over that, it will be compressed. When you're going down that, it will releases. So the person who is sitting on the vehicle feels smooth riding, or otherwise it is horrible for you. That is, the shock absorber is one of the excellent example for an elastic material. And rubber, metallic wires, that metallic wires definitely it has an elastic nature. Spider web, steel, graphene, some examples they have given for you. And the plasticity, I already told you, it never regain its original shape after removal of deforming force. So materials those show plasticity are called plastic materials. Are you listening?
Yes, ma'am.
Yes, ma'am.
டவுட் வந்துருது, நேற்று நிறைய முறை கட்டாச்சு இல்லையா, அதனால. So those materials are called as the plastic materials. These are all very common things only. In the விஷயங்கள், the elastic materials, in the plastic materials, these properties are all very familiar to you. இங்க என்ன விஷயம்னா, just once again I am repeating that for theory purpose and for examination purpose. I am repeating the concept through the physics. That's all. So when they ask what is meant by elasticity, very basically, very fundamentally only they will ask the question in exam. Just you should recall the meaning of that word. What is that? What is mean by that? If you should not leave the question, I am not studied the 2 mark, I don't write. You cannot say like that. Just you have to sit simply and just recall what is the meaning of elasticity, what are the materials around us have the elastic nature. Like that only you have the questions in your answer script. So just you think and write. What is elasticity and what is plasticity? And Hooke's law, and this law defines the elastic limit. According to this law, the stress you applied, as I already told you, both will be equal. ஒன்று விட ஒன்று அதிகமாயிடுச்சுன்னா that body does not face the elasticity, it becomes the plasticity. Elasticity will become plasticity. In the Hooke's law, it tells about the elastic limit. So within the elastic limit, the stress is equally proportional to strain. So stress is equal to strain into some constant, and that constant of proportionality is E. E is modulus of elasticity, okay, which depends upon the material being deformed or nature of deformation. எல்லாத்துலயுமே Young's modulus னு ஒரு modulus value calculate பண்ணுவோம். That modulus ன்றது it varies, depends upon the shape changes. ஒரு shape length, area, volume, only one angle அந்த மாதிரி change ஆகும்போது அந்த value change ஆகும். That's all. But that is a constant value. அது ஒரு number. So according to Hooke's law, you can define it in the simplest way. Within the elastic limit, stress is directly proportional to strain. Okay, so stress is equal to, stress is proportional, and alpha மாதிரி இருக்கிறது directly proportional. Inversely proportional na இந்த equation எப்படி எழுதுவ? If stress is inversely proportional to strain na எப்படி எழுதுவ இந்த equation?
Stress is equals to 1 by T.
1 by strain. Stress is proportional to 1 by strain. அந்த terms தெரிஞ்சா கூட நீ இத sentence எழுதிடலாம். So Hooke's law போது you have to remember stress is proportional to strain. So in definition, in sentence you can write, within the elastic limit, stress is directly proportional to strain. So stress is equal to some constant into strain. That constant of proportionality is known as the modulus of elasticity. So how do you measure the modulus? ஒரு மெட்டீரியலுடைய modulus, அதாவது elasticity-ய எப்படி measure பண்ணுவோம்னா, by finding the ratio of stress with strain. Ratio of stress to strain. Stress, the constant of proportionality is known as the modulus of elasticity. That is the term E. So in the next step, you should write it as stress is equal to E into strain, or E is equal to stress divided by strain. The E it has, we can study the different types of E. Can you remember what are the different types of modulus? E is the modulus of elasticity. I said it is a constant number. It is varied for different materials. This value is not constant for all the materials. Wood க்கு ஒன்னு இருக்கும், iron steel க்கு ஒன்னு இருக்கும், cardboard க்கு ஒன்னு இருக்கலாம், glass க்கு ஒன்னு இருக்கலாம். The value will be changes. This E value will be changes for all the materials. Okay, we all know that metal க்கு இருக்கிற elasticity wood க்கு இருக்காது. Okay, and the values measure பண்றதுக்கு தான் இந்த formula. இதுக்கு fundamental. This formula was arrived by Hooke's. E is equal to stress by strain. What are the different types of modulus you know?
Bulk modulus.
Yes, bulk
Young's
modulus,
modulus.
very good.
Young's modulus.
Young's modulus, very good. One more thing.
Modulus of elasticity.
இதுதான் modulus of elasticity. Modulus of elasticity தான். Young's modulus of elasticity is one thing. Bulk modulus of elasticity is the second thing. And the third thing is rigidity modulus. That is a rigidity modulus, third modulus. What is meant by Young's modulus of elasticity? Young's modulus of elasticity.
Length, for length, Young's modulus.
Yes, if the length, if the dimensional changes happening along the linear wise, that is the lengthwise ஒரு dimension change ஆகுது அப்படின்னா just you are taking the one rod, thin rod, metal rod. If you adding the load at the end of the rod, what happens? The dimension will be changes a little bit, that dimension along lengthwise, and the length மாறுது பத்தியா, அந்த type of modulus வந்து Young's modulus. You can find it. The definition of the Young's modulus can be written as the ratio of longitudinal stress to longitudinal strain. As per the definition of Hooke's modulus, simply modulus is equal to stress by strain. Adula first type of modulus is the Young's modulus. Due to the in Young's modulus, when you call it as a Young's modulus, if the changes in dimension happening along the lengthwise na, dimensional vandu only one direction. Here I am telling about only one directional changes in dimension. If it happens like that, that type of modulus of elasticity is Young's modulus of elasticity. இது வந்து நம்ம லேப்ல செய்வோம் by taking one wooden scale, அந்த மீட்டர் ஸ்கேல் பார்த்துருப்போம் லேப்ல 1 மீட்டர் ஸ்கேல் எடுத்துக்கிட்டு we will add the load at the middle, so that we will find by adding the load and removing the load. When we add the load at the middle, definitely the scale will bend ஆகுமா ஆகாதா? If you take a 1 meter scale, or if you take at least the 30 centimeter scale you have, if you pressed, give the pressure at the center and the stress in the center la kudutina, scale bend ஆகுமா ஆகாதா?
ஆகும்.
ஸ்கேல் பெண்ட் ஆகும்போது அப்ப அதோட டைமென்ஷன் என்ன, அங்க அது என்ன ப்ராப்பர்ட்டியை காட்டுது? டியூ டு த எலாஸ்டிக் நேச்சர், அந்த வுட்டோடைய எலாஸ்டிக் நேச்சர், இல்லைன்னா நீ வச்சிருக்கிற பிளாஸ்டிக் ஸ்கேல்ல இருக்கிற ஒரு எலாஸ்டிக் நேச்சர், அந்த எலாஸ்டிசிட்டி வேல்யூ இருக்கிற வரைக்கும் தான் அந்த ஸ்கேல் வந்து அது பெண்ட் ஆகும். ரொம்பவுமே ப்ரெஷர் கொடுத்து அழுத்தினா ஸ்கேல் என்னவாயிடும்? உடஞ்சி போயிடும். அப்ப அங்கதான் லிமிட்டை நீ கிராஸ் பண்ணிட்டேன்னு அர்த்தம். ஸோ தேர் வில் பி சர்டன் லிமிட், okay, to add the load to the object. ஏனா நீ கொடுக்கிற stresses, எவ்வளவு stress கொடுக்கறியோ, when the stress increases, simultaneously the strain increases. The stress is proportional to strain. Stress decrease ஆச்சுன்னா strain decrease ஆகும். When we add on the load or the pressure, இது எல்லாமே ஒரே வார்த்தை தான். ஸ்ட்ரெஸ்ன்றது மென்டல் டென்ஷன் நீங்க எடுத்துக்காது, சரியா? அது ஒரு பிசிக்கலா ஒரு நார்மல் லைஃபோடைய மீனிங் அது இருந்தாலும் the stressன்ற வேர்டு ஒரு இடத்துல மாறும். if you take the electrical connection, the stress is the electrical load. if you give more, அந்த ஒயருக்கு எவ்வளவு லோடு தாங்க முடியுமோ அவ்வளவு கரண்ட் தான் சப்ளை பண்ண முடியும். if you passes the high voltage, definitely it causes fire, கரெக்டா? ஸோ அந்த எவ்வளவு அதுதான் அந்த எலாஸ்டிக் லிமிட். இது எல்லாமே நம்மளுடைய எதுக்காக இந்த பிசிக்ஸ்ல இவ்வளோ பெரிய டெரிவேஷன், எதுக்காக கண்டக்டர்லாம் ஃபார்முலா அப்படின்னா, எயிட் டெரிவேஷன்ஸ் லீட்ஸ் த one step formula, and the formulas will give us the values of properties of the different materials. ஒரு வேல்யூவை அனலைஸ் பண்ணி தான், அந்த வேல்யூஸை வச்சு தான் இந்த லிமிட்டுக்குள்ளே இருந்தால் மட்டும்தான் இந்த மெட்டீரியலை இந்த இடத்துக்கு யூஸ் பண்ண முடியும். ஸோ இந்த வேல்யூ, இந்த யங்ஸ் மாடுலஸ் வேல்யூ, இதோட ரெசிஸ்டிவிட்டி வேல்யூ, இந்த மெட்டீரியலுடைய மெல்டிங் பாயிண்ட் வேல்யூ, இதெல்லாம் கணக்கில் வச்சு தான் அந்த மெட்டீரியலை ஒரு பர்டிகுலர் அப்ளிகேஷனுக்கு சூஸ் பண்ண முடியும். why we are using lot of derivation in physics னா இதுதான் காரணம். அந்த அப்ளிகேஷன் வந்து இது ரொம்ப ரொம்ப ஃபண்டமெண்டல். ஸோ physics is the highly basic to your engineering course. So y is equal to y என்ற the term is used to represent the Young's modulus. It is defined as longitudinal stress by longitudinal strain. Longitudinal stress என்றதுக்கு என்னன்னா F into, we all know what is stress. You have to go back to the formula. Actually stress is defined as the first time. Stress is defined as force per unit area, F by A. Strain is defined as you said, L by L, change in dimension divided by original dimension. You can write it as small l divided by capital L. So stress by strain போது மேல ஒரு formula F by A, strain போது small l by capital L. So the total Young's modulus y is equal to f into L divided by, that is f by a divided by change in dimension divided by original dimension. I think you can understood the formula. In the top you have y is equal to stress f by a divided by linear strain is delta L by L. Delta L is the change in dimension or change in length. If you add any load on the wire length L changes into delta L. Okay, so the force you applied for the unit area எப்படி measure பண்ணுவோன்றது ஒரு problem இல்லை. Area would a problem pi r square, you all know that A is equal to pi r square, that R for is cylindrical wire. Linear wire எடுத்தோன்னா directly you can measure the wire length using the screw gauge. அந்த wire அந்த length வந்து ஈஸியாக மெஷர் பண்ணி நீ டைரெக்டாகவே ஃபார்முலாவில் சப்ஸ்டியூட் பண்ணிடலாம். This and all you have the laboratory experiments. So F is m into mass into g, gravitational force. What is the value of g? அதுதான் இதுல
9.8 meter per second.
So louder சொல்லு. 9.8 meter per second square. It is the constant value. What is pi value?
3.14.
Okay, 3.14. You have to substitute everything on the formula. இதை வந்து உனக்கு 2 marks question answerல கேட்டாங்கன்னா they may give the values of other values, L value, delta L value. They will give, suppose I give the 5 centimeter wire, it due to the 5 kg load added to the wire, it extend to the 6 centimeter, 5.5 அப்படிதான் கொடுப்பாங்க. அப்படி கொடுக்கும்போது what is the Young's modulus னு question கேட்டா you should know the formula FL divided by AL. Simply you can write F small l divided by capital A capital L. If you know the meaning of the y FL by AL, you can directly substitute the values what are all given on the questions. You can substitute and find the answer for y. Okay. So longitudinal stress, it's nothing but it's a linear stress only. It is the tensile strength is applied along the length and it causes the change in length. The linear strength is the ratio of change in length to the original length. As one example is given for you. A wire of diameter 3 mm and length 4 meter extends by 2.5 millimeter. So 4 meter length is the original length. It extends by 2.5 mm 4.25. It's the total extension is 0.25. கொடுத்தது வந்து 4 meter, அடுத்தது millimeter லெவலுக்கு அது increase. The dimension 4 meter 5 meter extend ஆயிடாது. A small changes will be studied and that value is 0.25 mm. So the change in length is 0.25 centimeter. When a force of 10 Newton is applied, the formula is given F by A divided by L by L. So the final formula is F divided by A into small l மேல into again capital L. FL by AL. That is the formula. Y is equal to FL divided by AL. Are you writing the notes?
Yes, ma'am.
Then you note down this formula. Capital Y is equal to F into capital L divided by capital A into small l.
One second, ma'am. 1 second.
Okay. So using this formula, some 2 marks can be asked. They will be asking some 2 more questions. The next one is bulk modulus of elasticity. What is the meaning of bulk? Bulk என்ன அர்த்தம்? Total கொலாக்கியலா சொல்லணும்னா total overall. The bulk, the meaning of the word bulk means overall, the total volume. If you're giving the pressure or if you are giving the load or force to all over the body, all the sides, the total body is compressed. The whole body is F into, from copy from here, Y is equal to F into delta L divided by A into F into L divided by A into delta L. The delta L என்றது change in length. சரியா? delta L என்றது change in length. அந்த L என்றது original length. Capital L is the original length. ஓகேவா சரவணகுமார்?
ஓகே மேம்.
புரிஞ்சுதா? இந்த ஃபார்முலா கூட எழுதிக்கலாம், உனக்கு அப்பன்னா புரியும். Fனா என்னன்னு எல்லாருக்கும் தெரியும். F is equal to mg ஃபார்முலா, மாஸ் டைரக்டா கொடுத்துருவாங்க, g உனக்கே தெரியும். ஏரியாவும் அப்படிதான், ரேடியஸ் கொடுப்பாங்க, நீ டைரக்டா சப்ஸ்டிட் பண்ணிடலாம்.
ஓகே மேம்.
காவியதர்ஷினி உள்ள வர கேக்குறல என்ன? காவியதர்ஷினி கால் பண்றா, பட் ஹலோ பண்ண முடியல. பாப்போம். So, okay, what is the meaning of bulk modulus? Bulk modulus na என்ன?
மேம் ரொம்ப எக்கோ அடிக்குது மேம்.
அப்படியே வரேன் இங்க. இப்போ ஓகேவா? What is the meaning of bulk modulus of elasticity? The total all over the body you are giving the stress, so automatically the total body dimension will be changes. You are not giving the load or not giving the pressure on only one direction. See the diagram. If you are giving the pressure in all directions, the total body volume will be changes. So the application, which is we have the same formula. Actually bulk modulus can be defined as bulk stress divided by bulk strain சொல்லுவோம், or volume stress by volume strain. ஏன் volume stress ன்னு சொல்றோம்னா, volume means usually how when you measure volume, we want to measure the dimension of the total dimension of the body na, along length na L, along only area na length into breadth. The total volume they ask you to calculate for the cubical object I am telling. Okay, cylindrical, spherical ஒரு formula இருக்குன்னு உனக்கு தெரியும். If I'm here in this diagram, we have the cubical objects. So on this cubical object, பேசுறது கேக்குதா?
Yes ma'am.
Yes ma'am.
Okay. Slide change ஆகுதா?
Yes ma'am.
இப்போ bulk modulus தானே இருக்கு ஸ்லைட்ல?
Yes ma'am.
ஓகே, எனக்கு இன்னொரு இதுல மூவ் ஆகல. ஸோ பல்க் மாடுலஸ்ல உனக்கு டோட்டல் வால்யூம் சேஞ்ச் ஆகும், லென்த், பிரெத், ஆல் த சைட்ஸ், ஓகே, ஹைட், எவ்ரி திங் வில் பி சேஞ்சஸ். உனக்கு அந்த ஃபார்முலாலாம் தெரியும். ஸோ த ஃபார்முலா டு ஃபைண்ட் த பல்க் மாடுலஸ் ஆஃப் எலாஸ்டிசிட்டி இஸ் வால்யூம் ஸ்ட்ரெஸ் டிவைடட் பை வால்யூம் ஸ்ட்ரெயின். அந்த வால்யூம் ஸ்ட்ரெஸ்ன்றது, அந்த ஸ்ட்ரெஸ் பை ஸ்ட்ரெயின்ன்றது எங்கேயுமே மாறாது. யங்ஸ் ஹூக்ஸ் லால இருந்து மட்டும்தான் we are deriving all this equation. From the Hooke's law, the Young's modulus can be written as Young's longitudinal stress by longitudinal strain. The bulk modulus is written as volume stress by volume strain. The volume stress is force per unit area divided by change in volume to the original volume. The change in volume can be written as delta V. Again, you write the formula here. The bulk modulus is equal to F into capital V divided by A into delta V. That A is nothing but area, total surface area of the object, and delta V is the change in volume. Volume எவ்வளவு change ஆயிருக்கு அப்படின்றது தான் அந்த delta V. So volume strain is the ratio of change in volume to the original volume. The third type of modulus is rigidity modulus of elasticity or shear modulus. In the rigidity modulus, if you opening a door, actually we will call the opening a door is an example of moment of force. But here I am asking you, a door is fixed on the wall. When I'm not giving the full pressure to the total part of the door, only at the edge. One correct? Am I correct? We will giving the force or the load to only one part of the one surface of the door. In the same way, so one portion only moving. Like that, if any objects, its one side will be fixed. In this picture, see the first picture on this slide. In this picture, the top portion of the object, this object is fixed. I am giving the pressure to another side. Totally, if it is a 8-sided cube, cubeக்கு 8 side இருக்கு. In the 8 side la one side is fixed at the base. Its base is fixed. I am giving the force to the second side. The left side இன்னொரு 8 sideல ஒரு side fix பண்ணிட்டோம். ஒரு sideல மட்டும் I am applying the force na the body, the total volume or the length cannot be changed. Its bottom portion will be fixed. Only the remaining portion of the body and the remaining 7 side mein enna agum slightly deviated. Deviate ஆகும்போது angle will be created. So using that angle only we can measure the rigidity modulus. Here the body உடைய length மாறல, the body உடைய volume change ஆகல. ஏனா body உடைய one portion, one side fixed, remaining 7 sides are moved, causes some disturbance, causes some strain due to the force you applied on the other side. So this type of strain produced on the object is called as the shearing strain. Okay. So why we call it as a tangential stress? Now you are applying the shearing stress. It is you are applying perpendicular. That is the reason we call it as a tangential stress. So shear na angle. Angle one will change. The total body cannot move. Only the displacement causes the small change in angle from the bottom, from the original position. Original position la irundhu இந்த 20 degree ஆங்கிளுக்கு அது நகர்ந்திருக்குன்னு தான் சொல்ல முடியுமே தவிர அந்த பாடி எந்த டைமென்ஷன் சேஞ்ச் ஆயிருக்குன்னு சொல்ல முடியாது. It due to the rigidity modulus or due to the tangential stress I applied, perpendicular நான் அப்ளை பண்ணும்போது due to this force only the body slightly displaced to 20 degree from the original position. Am I clear to you? புரியுதா?
Yes ma'am.
அதுக்கு பேரு தான் shear strain. Okay, so the rigidity modulus eta is equal, we call the symbol as eta equal to tangential stress by shear strain. So tangential stress is F by A, the force per unit area, and the shear strain, that is delta tan theta வச்சு measure பண்ணுவோம். Okay வா? See the last line. Eta is equal to F divided by A into theta. Theta is the shear strain, and where theta and the theta is equal to tan inverse delta L by L dash வரும். The changes were considered to be very small. Very small என்னும்போது tan theta becomes written as theta only. Maximum cases in physics will, for the small values of theta, the tangent or sine or cosine values are considered to be theta only. Okay. So eta is equal to F by A into